Hi everyone, welcome back. This video is an example about the biconditional. We're going to fill out the following truth table with this sentence, in parentheses, not P or Q in the biconditional, and then in parentheses, if P then Q. So let's get started. So for P and Q, these are our two variables, so we have to fill out all the possible combinations, which in this case, as we've seen in previous videos, gives us this configuration. Now this column here is not P. That's just the opposite truth value of P. So let's do false, false, true, and true. Okay. This right here, not P or Q. This is a disjunction. A disjunction is only true when one of the disjuncts is true. So we're looking at these two columns here. I see in the first row, there is one of the disjuncts is true, in this case Q. In this second row, they're both false, which means the sentence is false. In this third row, they're both true, which means the sentence is true. And in this last one, we have not P as being true, therefore the sentence is true. Okay, that's this column. Now we have our P horseshoe Q. This is if P then Q. So we already know the truth table for this, at least we should. But just for clarity, we look at these two and we say the only time that the conditional is false is when the antecedent is true, in this case P, and the consequent is false, which is Q. That's this particular row. That's the only time it's false. Every other time it is true. Okay. Now we get to the actual biconditional. Remember, the biconditional is true only when there's matching truth values on both sides of it, both halves of it. So we pretty much look at these two columns and we say, okay, do they match? If they do, it's true. If they don't, it's false. What we see here, true, true, that means that they do match. So the answer is true. So false, false, remember, it's whether they match. So the answer is true. They do match, which is true. And then this again, true, true, and this, true, true. So look at the conclusion here. The conclusion is showing us that it is true in all cases. Now, I pointed this example out because it's kind of unique. What this example is saying is this left side of the sentence and this right side of the sentence are equivalent. So in other words, not P or Q is actually logically equivalent to writing if P then Q. So if you think about that, it's actually quite interesting. We don't even need to use this horseshoe symbol because the not and the disjunction, those would suffice to get the sentence to be the exact same. So this is a way you'd prove that. And this is also an example about the biconditional. So I figured I'd do 2 in 1. So that's pretty much the basic idea. And let me know if you have any questions. If you have any questions, you can email me or you can just leave a comment on the video and I'll look at that as well. Yeah, that's it. Thank you.